today's lesson is about using angle bisectors. The neat thing, I think these are one of the simplest ones to do. So whenever the angle bisectors cross each other, they create an incenter. This is the point where the angle bisectors cross each other. It's the point where they cross each other. So you got to think, what does that look like? So that's what I'm going to show you now. Out here to the side, let's go ahead and draw our triangle. Remember, we're going to do acutes because they're the easiest right now, and we'll modify from there. So angle bisector. We are bisecting an angle. The first step is you bisect the angle. So what's it mean to bisect an angle? Cut into two equal parts. So I'm going to go down here, maybe look at this angle right here. When I look at this angle, I want to be able to divide it into two equal sections. When you have a piece of paper, you can actually make a fold right here and make sure these lines fold onto each other. We'll do that a little bit later. But for right now, we're just going to kind of eyeball it. We want to make sure we're kind of in the middle. So you all watch me, tell me if it's in the middle or not. Somewhere in there. I'm going to do the next one now. Say up or down. All right, somewhere in there. And the last one. All right, so those three right there would be my angle bisectors. Now, the key thing, you have specific marks that are needed on this shape. When you bisect an angle, what kind of marks should you put on the angles? Those little congruent arcs. So these two are congruent. These two should have doubles. These should have triples. Those are showing your angle bisectors. So the point of concurrency on this one is called the incenter. And it's right here. That point is the incenter. Centers are always on circles. So I'm going to draw a circle with its center right there and see what happens. So I'm going to select this circle and see what happens. Let's try it one more time. All right, this time I'm off just a little. All right, so that's where it should be. The center should be right there. So I was off slightly. I eyeballed it, which we'll be doing better later on, but that's pretty good. So what this should show you is this. Make a quick sketch. This one's definitely not going to be perfect. If your incenter is here, your radii would be going to these sides. And it will be perpendicular to these sides. These segments would be the same. So if I transfer that circle up to this shape, it would look something like this. Those would be the spots at which that circle touches. Obviously not a great circle. But that's where it would touch on the sides. That means these distances would be the ones that are the same length. Here's another showing of how it could look on an obtuse triangle. We could bisect these three angles with these red segments, draw our incenter and our circle inside the triangle, and you could see these green pieces would be the congruent segments. They're perpendicular to each side. The key thing, this angle bisector does not hit the midpoint. That would definitely not be the midpoint of that side. On example 1, it says find the measures of angle CBE. So CBE is right here. That big angle. I want the measurement of that big angle. Well, if these segments are the same, and they're perpendicular there, then these angles will be the same. So if that's 31, this one right here is 31. But it wants the total. So I could do 2 times 31 degrees, and I get 62 degrees is my final answer there. Sorry, I highlighted CBD. I should have highlighted only CBE. And that one quickly is 31. So CBE is 31. I accidentally did angle CBD. And that one is 62. Okay? So I'll be asking both of those on the test. So tell me the small one and then tell me the total. Sorry about that. All right, example 3. For what value of x does P lie on the bisector of angle J? This is a pretty easy one. Remember, if it's supposed to be an angle bisector, you'll have a couple things occurring. You'll have a bisected angle, so that would be KLJ. KJL is the one that will be bisected, so these pieces will be congruent. And then wherever that point is, it's kind of like the incenter. It has to be perpendicular to that side, and your circle would kind of be out here. And if that's true, then these segments are congruent to each other. So if they're congruent to each other, I can set up the equation. I can say KP is equal to what? PL. Now how long is KP? X plus 1. And how long is PL? 2x plus 2x minus 5. And this is very easy to solve. What step do we do first? Subtract x is the good first step. I'm left with that canceled, and 2x minus 1x is still 1x, or just x. Get x alone by getting rid of this minus 5, so do the opposite. And 1 plus 5 is 6. X is 6. Does that answer the question? For what value of x? Did we answer that? Yes, we answered that question. Here's part of the picture that I drew earlier as like a quick sketch. So the key thing is these are my angle bisectors. I'll draw in my angles real quick. So I did my singles, my doubles, now I'll do my triples. Whenever you have your angle bisectors and they all cross, they'll hit at a point. That point right there, I would say point P is the incenter. However, is AP congruent to PC? Would those angle bisectors be congruent? Definitely not. Remember, incenter has that circle inside that triangle. So it's kind of ugly, but it's something like this. So if that's my incenter, these would be my radii, and these pieces would be my congruent segments. They're perpendicular to each side, as we noted earlier. I got to name the pieces that are congruent. PD is the same length as PE and what? PF. So those are the 3 green segments that I drew inside that circle, and they're acting as radii inside that shape. Example 4 is a little bit more challenging. It wants you to think in a different way. On this one it says L is the incenter of FHG. Well, if it's the incenter, an incenter is created by what special segments? Angle bisectors. So incenter, angle bisectors. And it tells you that right here also. Angle bisectors, there's the incenter. They always go together. What it wants you to do, though, is it wants you to find LK. So I'm going to highlight LK. It's right here. That green piece. The problem is, do I have any numbers directly around LK? No. That means I'm going to have to use these numbers way over here. Right now, I know a couple others. I see this is a 15, and this is a 12. And actually, if I connect them with IL, I see I have a nice little shape. that little shape can be drawn out over here. I'll kind of blow it up a little bit. It's 12. This is 15. Do I know any other thing about that triangle? I should have a 90-degree angle right here. If this is 90, linear pair right beside it would also make that a 90. And we know a lot of stuff about right triangles. We know how to find a missing side on a right triangle. What famous formula should I use for that? Pythagorean. And what is the Pythagorean theorem? C squared equals A squared plus B squared. This is the better way to use it. It's a little better than ABC. It's a little more diverse. It applies to geometry a bit more. So, what goes in for C? 15. We always put the longest piece in for C. 15 is the hypotenuse. It's the longest piece. Definitely goes in for C. We'll do A is 12, and B we'll say is our unknown piece. We'll call it X. What's 15 squared? What'd you say? 225. 12 squared is 144. Then we have X squared. We got to do a little algebra to get X alone. What should we do? Subtract 144. What happens when you subtract 144? What do you get? So we get 81 on that. So when those cancel, we're left with 81 is X squared. How do I get rid of squaring a term? Square root it. So X is the square root of 81. And I know that's exactly 9. So this piece right here that was missing is now 9. That means IL right here is 9. Does any of that information help me find LK? LK is also 9. That's a property that we learned. When we have an in-center, we have that circle inside the triangle, in-center, inside, and these pieces will be congruent. We just found that IL is 9, but we should know that it's also the same as LK. LK is also 9. Those are the congruent segments in that shape. Here are a few checkpoints. The first couple ask you to solve for X. The third one says, do you have enough information? And number 4 asks you to find some pieces that refer back to example 4. All right, these are pretty quick. In these pictures, this is critical. They cross right here. There's their point of concurrency. It's where they cross. These segments are congruent. That relates back to the in-center. So the key thing you have to have for the in-center, these pieces would be congruent. Then they would come down and make these 90-degree angles. And they have to be 90-degree angles. Therefore, that would make these congruent angles. It would be an angle bisector. So I got to set those congruent to each other. Oops, that's minus 5 equals 2x plus 5. First step, subtract 2x. Add 5 to each side. X is 10. Kind of similar over here. Now we have these angles are congruent and they're 90, so these would be congruent. We want these to be congruent, so we'll set them equal to each other to figure out what that value needs to be to make them congruent. So 7x plus 3 equals 8x. Let's get rid of the small x. It'll work nicely. 3 is x. X is 3. Those are pretty simple problems. You should be able to fly through those. Now number 3 says, do you have enough information to conclude that AC bisects angle DAB? What are the key things that I pointed out up here that you needed? Right angles and the congruent marks. I have the congruent marks. Do I have right angles? Not right angles. Here's what some other people thought about. They redrew those triangles kind of out here to the side. They know that these angles are congruent. These segments are congruent. Can I add any more on that shape? I can add reflexive. Can I prove those triangles are congruent? If I can't prove they're congruent, then I can't add marks here. However, if these were 90s, here's what would occur. If they're 90s, you know that, you know this, that's definitely HL, so you could prove those angles. So this does tie back to old stuff. If you have these 90s, you can look for HL. Be careful. This did not have those 90s. This does relate back to old stuff. So, do we have enough information on this one? We talked about it right here. We said no, not enough information. We need those to be 90s. The last one, it says JL is 25 and what is that? JI is 20. JL is 25, JI is 20. So let's go back and look at that picture. JL and JI are what we need to focus on. JL and JI. So there's that little right triangle that we should focus on. I'll make it a little larger. JIL. It said JL is how long? And JI is 20. Can I use Pythagorean Theorem? Yeah, c squared equals a squared plus b squared. This should be your setup. Longest piece, hypotenuse, goes in for C. I'll put 20 in for A, and I'll leave X for that unknown side. What do you get when you solve for X? Go ahead and tell me the solution. 15. All right. Homework. So once again, the question asks for finding LK. And LK is right over here. It's that perpendicular piece. So I need the perpendicular piece for this one, and we just found it was 15. So LK is 15. Done.